In this video, we're going to talk a little bit more about sun angle, and we're going to talk about how to calculate sun angle. Now, this may seem like a boring math problem, but in reality, it's actually very important because our weather models that we rely on, or meteorologists rely on to forecast the weather, a part of the code that is written for the weather models is determining sun angle for different locations throughout the entire globe. And so it's important to understand the angle of the sun because that will dictate the amount of solar energy that is received at that location. So when we look at the Earth as a whole, what do we notice? Well, we notice that the Earth really has 3 points of latitude where the sun is directly overhead at certain times of the year. So during the summer solstice in June, the sun is concentrated in the northern hemisphere and is actually directly overhead at what we call the Tropic of Cancer, which is at 23.5 degrees north. During the winter solstice, we know that the sun is concentrated in the southern hemisphere. So the southern hemisphere during the northern hemisphere, or what we know as our winter months, that is summertime for the southern hemisphere. And that's because during the winter solstice, or right around December 21st to 22nd, the sun is concentrated right at the Tropic of Capricorn, which is 23.5 degrees south. So the sun's concentration really just varies between the Tropic of Capricorn in the southern hemisphere and the Tropic of Cancer in the northern hemisphere. Now during the equinoxes, this is like the checkpoint for the sun on its way to either the Tropic of Cancer or the Tropic of Capricorn. During the equinoxes, the sun is directed right over the equator. And so during the equinoxes, that means what? Equal. The Earth receives equal amounts of solar energy on those 2 times of the year, and that's when the sun is concentrated directly over the equator. Now, when we start to talk about how do we calculate sun angle for different locations throughout the year, our first step is to know where is the sun directly overhead for certain dates throughout the year. And so this is really the starting point. You can think of like an amusement park map where you open the map and it says you are here, and you can use that to gauge where you are throughout the amusement park. So it's the same idea when we talk about calculating sun angle. You first need to know where is the sun directly overhead. So we know that the sun is either going to be concentrated in the Tropic of Cancer, 23.5 degrees south, the equator, 0 degrees. It's neither north or south, it's just the equator, 0 degrees, or it's concentrated in the Tropic of Capricorn, which is 23.5 degrees south. So the sun either varies between 23.5 degrees north or 23.5 degrees south, and basically just keeps rotating or keeps moving between those 2 locations throughout different times of the year. So you can use this tool, which is called the Analemma, to figure out where is the sun directly overhead. So let's pick a date, let's say April 1st. I want to know where is the sun directly overhead for April 1st. And so what's interesting about this is that here is March, right? Now we just experienced the spring equinox, so we know that the sun has just passed the equator and we're now moving into summer months, so the sun is now slowly becoming more concentrated in the northern hemisphere. So if I want to know what it was for April 1st, here's March 30th, 31st. So if I just move to the left here, I can see that the sun is right about 4 degrees. So that's where the sun is concentrated. So for April 1st at noontime, the sun will be 90 degrees at 4 degrees north latitude.